A proportion compares, one ratio to another ratio. Shh. How do we solve these proportions? No? Ah. Was it? We have to cross multiply. Shh.
Oh, did we do this in like 8th grade?
You should have done this before, yes.
And then you do like 2 times. Oh, wait, that was last week.
Now, very quickly, because I also teach Algebra 2, how do I know I can cross multiply here?
Because it's a fraction.
So, don't write this down. Don't write this down. Why do I not cross multiply here?
Because it's an X.
Oh, what is different between these ratios versus a proportion? What is different?
Oh, it's a multiply, not an equal to.
Very good. So, when is the only time that you cross multiply? When two ratios are set equal to each other. How would I solve this multiplication? What do I do? No, you do not cross multiply.
Sorry, I was not thinking.
You just multiply straight. So x times 3 is?
3.
And what's 2 times 4? Do you see the difference?
Yeah.
All right. So back to our proportions. How do we solve these proportions?
Cross multiply.
You have to cross multiply. So we multiply x times 4 and 2 times 24. What is x times 4?
Oh, wait, I mean
Oh boy.
Hold on. I was doing 2 times 4. Don't judge me.
4x equals or plus 48.
Wait.
4x equals, what's 2 times 24?
48.
And then what do I do?
You divide.
Good.
By 4x. On both sides.
What is 48 divided? Oh boy.
14. 12. 12. Something.
15.
I said 14, alright? I did my math wrong.
12. Good. Do we have any questions so far? Again, this is review. None of this should be new. This is not geometry yet. This is not geometry. We have not applied this to similar triangles yet. So next, how do we solve this proportion for x? Cross multiply. It puts an equal between them.
Oh, the bottom fraction.
It tells you they're equal.
What is it?
This example tells you they're equal.
Oh, you're right.
Okay. Now, this one's a little tricky. Why is this different than the other problem?
X plus 2.
Oh, in the numerator on the left-hand side, we have 2 terms.
So it'll be
How do we multiply 2 terms times a single term? We put the 2 terms in parentheses. So then we just write 4 times x plus 2 equals, what is 8 times 2? 16. Thank you. Then what do I do? What did you say to do, Matt? Distribute the 4. What is 4 times x? Did anyone not get these? And what is 4 times 2? Now what do I do?
Subtract by 8 on both sides.
Good. Subtract 8 over. What is 16 minus 8?
8.
And then?
And then you divide by 4.
X equals 2.
And x is 2.
This is the most simple stuff we've done all year.
We're gonna add it.
Yes, because this is review. This should be review.
Yeah, I like review better than actual.
We have a lot more notes and my voice, my throat is dying right now.
I'll take over.
Oh, yeah.
That'd be a great teacher.
I think Kyle would take
I'd be
over.
non-stop taller.
All right. So now we're going to take what we just recalled about proportions and apply it to similar triangles. So we learned at the beginning of class that similarity means what? Same shape. Same shape. So two shapes are similar if they have, if they have a,
Comment.
constant
Constant.
scale factor. So you don't need to write this. What this means, if I tell you two triangles have a scale factor of 2 or a ratio of 1 to 2, and this side length is 6,
Oh, then you're gonna multiply by 2.
ah,
And it's
so
just gonna be 12 on that side.
this side is 12.
Easy.
If this side is 4, what is this side over here? 8. If this side is 20, what is the side on the bottom?
What's 8 times 3? What? 40. 8 times
40. Should be 40 here. So, do all of these sides have a common scale factor? What is it? What is the scale factor? 2. Do they all have a common scale factor?
Yes.
So are these two triangles similar to each other? Oh, yes, they are.
They are my guy.
So now we apply what we learned about proportions to similar triangles to solve for x. So I didn't mean this here. Are these triangles similar? I meant solve for x given triangle ABC is similar to triangle
Yes,
ABCDEF.
they are similar.
Good, but that's not what I'm asking.
Because the scale factor is times 3.
Good.
Bam.
But we can't be 100% sure about that because we have x on a side.
Yeah, but you see?
Yeah, you just divide.
10
You divide
times
18.
3 is 30. So then you use
Yeah. I'm telling you they're similar though.
24.
So, yes, it is easy to see the scale factor here. Are you listening? Yes, it is easy to see the scale factor here. However, do you think that this is going to be a test problem? No, it's too easy.
Ah.
It's too easy. So what we have to do is set up a proportion here because it won't always be so easy to see the scale factor. So, how you set up a proportion? What side is X, the side EF, similar to on the first triangle? How do you know that?
It's in the same spot.
This could be a triangle turned on its side. You don't know. How do you know EF?
Because yeah.
Ah, you look at the similarity statement. Here, EF is your second and third letters. What are your second and third letters in the first triangle? So EF is similar to BC. So we have one ratio all set. We've planned it out in our heads. We have one set of sides that should have a common scale factor. Then we have to choose another set of sides. It doesn't matter which you choose. I'm going to choose the 18. This side ED is similar to what on the other triangle? AB, because it's first and second. So now I have all the information I need to set up my proportion.
How do you draw that good?
No, because it just like auto.
So, side X is similar to what on the first triangle? 8. So I put X over 8. And side 18 is similar to what on the first triangle? 6. Now, do you think that I could have done this? Why not?
Isn't the bigger number?
Because I put the second triangle up top. You see how I put X up top? I have to put the second triangle up top in the second ratio. You have to be consistent here. 18 over 6. Now what do? I have to cross multiply. So I multiply. What is X times 6? And what is 8 times 18? And then what do? By 6. What is 144 divided by 6?
27 minus 3.
Can't you just like divide 30 by 10 and get 3 and do the same thing with the other one?
For sure. That's what I'm saying. This problem, it's very, very easy to see the scale factor because you can just do 30 divided by 10 is 3. So you know you're just multiplying by 3 every time.
Like,
However,
even if it's 13 million and some other number congruent to it, you can just.
I'm about to show you a problem that's actually a test problem. And you'll see why you cannot see the scale factor. So, what I want you to do right now is tape this piece of paper in on page 13. All right. Before we get into solving another similarity problem, we do need to go over what is called the similarity postulates. Now, what have we dealt with before that has the word postulate in it? What? Okay, I still haven't heard it yet. What postulates? Congruence postulates. And remember at the beginning of class today, if two things are congruent, are they also similar? Yes. So if two triangles are congruent, and we've proven they're congruent by the congruence postulate, are those two triangles also similar? Yes, they are. So do you think that all the congruence postulates also prove similarity along those terms? Do you see where I'm getting at?
Wait, what did you ask? What did you ask?
All right, so one more time. Two triangles that are congruent, are they also similar?
Yes.
All right, so if we've proven two triangles are congruent using congruent statements, have we also proven them now similar?
Yes.
So do you think if I'm looking for similarity postulates, I can include all of the congruence postulates to prove similarity? Okay, so what are the congruence postulates?
Hey, everyone was thinking.
Oh! Side, side, side. Side, angle, side. What else? Side, side, side. Side, angle, side. What else? ASA. What else?
No. Stop. With 2 S's.
No. AAS. What else? There's one more. HL.
Kevin said that again.
These are all of our what?
Kevin said it like a whole 5 seconds before you. You're struggling just didn't hear it. I can't even do it.
Congruence postulates. Shh. So, if we have proven two triangles congruent using these congruence postulates, we have also now proven similarity. So all of these postulates are also considered similarity postulates. Now, because similarity is only based on shape, we do have one more postulate that is not a congruence postulate. What do you think that one more postulate is? Can anyone take a guess?
No, that's HL.
Do we have any guesses?
What does it start with? What letter does it start with?
Starts with an A.
What was the question?
Do we have a guess as to what? Oh. AA or angle.
Would there be an S?
You don't, and I'll show you, you don't need 3 angles.
Why are you using a double A battery?
So here, if I draw 2 triangles, and I have this triangle 30, and this one 30, and this one is 60, and one is 60, are these congruent by AA? Yes. We have an angle congruent to an angle. I mean, oh my gosh. Are these 2 triangles similar by AA? Yes, they are. We have 30 congruent to 30 and 60 congruent to 60.
Is it because there's only 2 numbers?
Now, what is the last angle? Have to be in this triangle. It has to be 90. Do we need it there? No, we know it has to be 90. What does the last angle have to be here? In the second triangle, what does that have to be? 90. So do we have to have 3 angles? No, we know that if two angles are the same, the third has to be the same. So all you need is 2. That's why it's only 2 angles. AA.
So like if you put like 80 and 80, you would know that the other one would be 30,
20? Yes.
20 or whatever.
Yes. Right? I mean, how many degrees does a triangle have to add up to? 180. So as long as we have 2 angles, we know what the third has to be. Don't overthink it. Just know AA is a similarity postulate. All right. Go ahead and copy down this example. Oh, I'm working it. I'm working it. So, this problem tells us that DE is parallel to CB. So I'm going to mark DE parallel to CB. Knowing that these 2 sides are equal tells us what about this triangle? No. First of all, how many triangles do you see here?
2.
Oh, how many? 2. There is a small one. Does everyone see the small one?
Yeah.
And then there is also this big one. Do you see the 2 triangles? Because DE is parallel to CB, these 2 triangles are what? Similar triangles. If the 2 sides had not been parallel, you don't have to draw this. Say, for example, it had been that. Are those 2 triangles similar? No. Right. I mean, do they look similar at all? Do they look like they're the same shape? Now, guys, do you think when I say these 2 triangles, I'm talking about this shape down here? No.
So is that line?
I'm talking about the small triangle and also the big triangle. So yes, they are still both triangles, but they are not similar. When we have the 2 bases being parallel, yes, the small triangle is similar to the big triangle. So now, how do we solve for x on 2 similar triangles? We have to set up a proportion. We set up a proportion. Before we set up a proportion, we have to figure out what the similar sides are. So I'm going to start with x. X is similar to what? on the big triangle? Where are you getting that from? Ah, so is x similar to x plus 1, you think? Is x plus 1 the entire length on the big triangle? No. Ah, so to get what x is similar to, I need to add the two parts of the big triangle together. So what is x plus 1?
2x.
Ah, so the entire length is 2x plus 1. So what is x similar to? 2x plus 1. Then over here, x plus 2 is similar to what on the big triangle? Right. I need to add together x plus 2 plus what? So what is x plus x? And what is 2 plus 6? So what is x plus 2 similar to? 2x plus 8. Perfect. Do I now have all the information I need to set up my proportion? Oh, yes, I do. So, x is similar to what? On the big triangle. What needs to go up top on the second ratio? X plus 2, which is similar to 2x plus 8. Does everyone recognize or understand how we set up this proportion?
Yeah, you just added the
right.
Side length, and then you took the smaller triangle, and then you put that over the big line.
Perfect. So now all that's left is just solving for x. So how do we solve a proportion? You cross multiply. Now, we're multiplying x times 2x plus 8. We're multiplying one term times two terms. What do we do to multiply one term times two terms? You put parentheses around the two terms. So x times 2x plus 8 equals... Now you're being dramatic because we're not to the hard part yet.
Oh my gosh, I'm never going to get geometry.
This is algebra right now.
Algebra.
We're not even to geometry yet.
No, the only part of this that is actually geometry is setting up the proportion.
The whole year we have not been doing geometry.
Yes, we have. The only part of this problem that is geometry is setting up the proportion, knowing which parts are similar and setting up your proportion. Solving the proportion is algebra. So now, what do I do when I'm multiplying one term times two terms? I distribute the x.
What does that mean? Does that mean like you add another x?
So this is what everyone's been struggling with all day.
Wait a minute.
What is x
it's 1
times 2x?
Yes, 2x.
What is, don't write this down, what is x times x? X squared. X times x is x squared.
See, this is all the
So, what is x times 2x? And what is x times 8?
8x. Oh, I remember this from algebra now.
I really didn't like
Now,
Yeah, I didn't
shh, Matt, I need you to stop talking. Now, what do I do when I'm multiplying two terms times two terms? Or in algebra, this was called multiplying two factors together to get the polynomial form.
I don't remember that.
Polynomial form.
There's actually three ways to do this. Can someone give me one way?
Ask your teacher.
Divide.
You can't combine
Multiply.
one is a squared and one is
We are literally multiplying here, but there are methods to doing the multiplication. So don't say divide. We're not dividing. We're multiplying.
I said multiply.
Oh, thank you, Brooke. All day. You are the only one that gave me something. How do you multiply two terms?
That's messed up. You put it in like that little square box.
Ah, you do the box method.
Biology? You put like the 2x, you put like the 8, and then you put like something similar. I don't know. I forgot.
This is why I learned in 4th grade.
Now, shh. This is actually not my preferred method, but I know this is how you learned it.
Can you teach us a more simple way instead of this way?
I was taught just to distribute everything.
Well, let's do that.
No, we'll keep the box method.
3x.
We just have
What
to
is
make it windows on our
2x times x?
Oh, 2x.
X or 2x squared.
Good. And what is 1 times x?
1x.
And what is 2 times 2x? And what is 2 times 1?
Hold on.
What are my like terms here?
X.
And? Good. So, when I'm writing this out, what is my answer to multiplying these two polynomials together? 2x squared,
Plus 5x.
5x plus 2. Good.
So we're not multiplying the x and 4 into the
No, you add them, combine them. All right. Now, they did go easy on you. They did go easy on you because they made it so that, guess what? What happens here?
Oh, it cancels out.
Oh, are you dealing with x squareds at all? No. So do you have to factor? No, thank heaven.
Remember the factor rainbow?
Remember factoring?
I doubt.
No?
I do.
Well, good. You're going to have to know how to do it in Algebra 2, though. That's all you do in Algebra 2 is factor.
Are you serious?
Yeah.
What is that thing? It's like what's related, what goes in the...
Right.
Yeah, okay.
So now I pull down my 8x and my 5x and plus 2. Now everyone should know how to solve this. What do you do?
Wait, do you really have to put the 2x squared? Or can
You
you
gotta-
just like put
yeah.
it in the calculator and then put that in? Simple.
What?
You're just subtracting it, so there's
Do you
not
have
any-
to put 2x squared, or can you just like...
It just cancels out. It just turns into a 0.
I wasn't asking you, Einstein. Okay?
So what is x equal to here?
You're Einstein that lost his chromosomes.
2/3.
I don't think you can lose chromosomes.
And we're done.
Die.